Hi everybody, it's Mrs. Hopley from the Beachmont School, and today we're going to be practicing with the affixing zero rule. So this rule helps us when we're multiplying by numbers like 10 or 100. So we'll do one quick example together. So in the example 6 times 10, we may know the answer to this, but we're gonna practice the skill anyways. We can cover up that 0 in the number 10 and treat this like it's 6 times 1. I know 6 times 1 is 6. I'm gonna go ahead and underline those digits. 6 times 1 is 6. And then the 0 that I covered up, I'm going to affix, attach to the end of my product, and that gives me 60, which we know this is true. 6 times 10 is 60. All right, let's try with a more difficult example. Let's try with 60 times 10. So now we have a few different zeros in here, and I'm actually going to show us two ways to solve this one. The first way, we can go ahead and cover up both of those zeros. So I'm going to, again, treat it like it's 6 times 1 is 6. So there's 6 times 1 is 6. And then since I covered up two zeros, I'm going to affix those to the end, and that gives me 600. Another way we could do this with the very same equation is to just cover up this second 0 here. So we could do the equation 60 times 1. I know 60 one time is 60. And then I just have to affix the 1 0 I covered up, and that also gives me 600. So that's the affixing 0 rule. This also works with the opposite operation of division, which makes sense because we know when we have the inverse, we can flip this equation around to be division, and it will be true. So let's try this last one. So 600 divided by 10. So let's think about this for a second. If when we're multiplying, we're affixing a 0, that's, tacking that 0 onto the end, attaching it, we're bumping the place value of that 6 over one place to the left, it's getting 10 times greater. What do we think we might do when we're dividing by 10? So the opposite. So we want the 6 to shift over one place to the right, and it's going to get 10 times smaller. When we divide by 10, that means our number is getting 10 times smaller. So the way we do this strategy is we look at the number of zeros we have. So we have 600 has two zeros. We're dividing by 10, which has just one 0. So we need to take 1 0 away from our dividend, the largest number we're starting with. And we're going to move this over one place. So instead of it being a 3-digit number with the 6 in the hundreds place, the 6 is now in the tens place. So it moved one shift to the right because we divided by 10. Got 10 times smaller. So when you're dividing by 10, instead of, affixing 1 0, you're taking 1 0 away. So we can kind of think about it like that. All right, let's do another example with that because it's a little bit trickier than the multiplication rule. Let's try 7,100 divided by 10. Okay, so I know I'm going to get 10 times smaller. I'll just use the less than symbol. So I'm going to think about taking one of these zeros away for my quotient. So I'm still going to have the same digits. If you look at all of these examples, the digits are never changing. So we started with 7, 1, 0, and 0. We're going to keep those same digits. We're just getting rid of that last 0 because we divided by 10. So that 7 that was in the thousands place is now in the hundreds place. It shifted over 1 place to the right. All right, let's use that same number, 7,100. For our last example, this time, we'll divide by 100. So this is different. So now we're dividing and we have 2 zeros. What do you think we're going to do? If you said get rid of 2 zeros, you're totally correct. We're going to take the 7,100 and shift it over 2 places to the right. So the 7 that was in the thousands place is going to shift over 1, 2 times, and that takes us to the tens place, which is the same as getting rid of those 2 zeros. So 7,100 divided by 100 is 71. One final thing before we sign off. How could we check this? If we're being precise mathematicians, we always want to go back and check our work. How could we check that? We could do the inverse. So let's see what 71 times 100 is. And we can use the traditional affixing 0 rule, the multiplication version, to check this. So I'm going to cover up my 2 zeros there. 71 times 1 is 71. Then I'm going to affix 1, 2 zeros. 1, 2. What's this number missing? A comma. And we want to wait to do the comma until the end, after we've affixed our zeros, because we need to count how many digits we have. So I know these 1, 2, 3 digits together make up the ones period. So that's where my comma goes. And do we get the same answer, 7,100? Yes. All right, everybody, that's the affixing 0 rule. Good luck.